All right. So let's look at loops. We talked about loops already, didn't we? Or not? Did we talk about loops?
Yeah.
Did we talk about do while loops? We covered this already. Huh? We talked about for loops.
Yeah.
So we did this. So you need to be working on these assignments here. These assignments involve loops. This is the hardest one, factoring numbers. Here's some example quiz questions. And I should expand these quiz questions to include solving these problems as well. Has anybody got to these yet? We talked about prime numbers already, didn't we? We did that. All right. Do you want to just quit? I mean, is there anything else you want to talk about? I think I covered this. And you haven't started on these yet, so it might not be, and I've already covered a lot of this. You got to get to this one here. This one's the most fun. The answer is very small. It's a tiny program. But you have to think about it to get that to work right. This is prime function is I should put in here in the example programs, example quiz problems. Any problem from the above exercises? And then I got to renumber these. So what about these? You want to do some of these together?
Yeah.
All right, let's do some of these together. Just forgive me for a second. I'll renumber this. So this is 2, 3, 4, 5, 6, 7. So I started putting the answers in here. But it's not a good idea to just look at the answers. You should try to solve these problems without looking at the answer. You could check the answer later. And these are possible answers, not the only way to do it. Let's look at this one here. So what does this print when this code runs? Well, we can just plug it into a program and run it, but that won't do us any good. Look at this one here. I'll just use this to keep notes. Let's do this one right here. There's only one variable to keep track of. It's I. So I'll just make a little note on my exam paper that I'm going to keep track of I. Initially, it's set to 3. That's what we do in the first line. And then, this is inconvenient, so I'm going to copy that. There we go. So I is set to 3 in line 2 here. Well, let's call it line 1. And then in lines 2 through 5, that's one statement. So this is the first statement. When the first statement completes, we do the second statement. And then when the second statement completes, the code is done. So we do things sequentially, except this statement itself is a compound statement, a complex statement. It has substatements in it. And things are done semi-non-sequentially inside the substatements. Inside this statement. We're going to repeat the substatements, lines 3 and 4. We're going to repeat those while the loop condition evaluates to true. So the loop condition depends on the variable I. We just simply have to track the variable I. Now, for the loop condition to become false eventually, I will need to change, and that's done here in line 4. The substatement shown in line 4 modifies I. So when we start the loop, I is 3, so I is less than 27. That means the loop condition is true. So we'll print I plus 1. We're going to print 4. I'll do it like this, output. We're going to print the 4. This doesn't modify I, it only uses I. We take I and we read what I is 3. We take the 3 and add it to 1, we get a 4. We print the 4. We don't modify I. So there's no assignment to I here. There's no modification of I. We're reading I, using I. What happens is this expression that I have highlighted, I plus 1, that becomes evaluated. It becomes 4. It evaluates to 4. We print the 4. And then in the next statement, that's an assignment to I. This statement will modify I, not the previous statement. So I times 3 is 9, and we assign 9 to I. So 3 becomes 9. And then we return to the loop condition because we're at the end of the substatements. We check the loop condition. The loop condition is true because 9 is less than 27. So we do the substatements again. We print I plus 1, but I is now 9, so we'll print 10. And then we do the second substatement in line 4. I, what's I? Is it 10? This is half of you will think I is 10 because that's why you got to keep this straight. 10 is what we printed. 10 is the result of adding I plus 1. But I was 9, and we never modified I. Don't get confused there. I is not 10. I have a record of it right there. We never made I 10. I'm making a big deal about this because so many people get confused on this. It's just a matter of keeping your thoughts organized and practicing careful thinking, I guess. Is that the right word for it? So I is 9. 9 times 3 is 27. And we assign that to I. So I becomes 27. Now we go back to the loop condition. Is the loop condition true or is it false? It's false. 27 is not less than 27. And so we're done. So the output is 4 and 10. That's the answer, 4, 10. Does that make sense? You have to practice this, right? And you can't be kind of sloppy in your thinking. You have to be clean and sharp and focused. So you have to practice that. So these are all similar. Let's look at another one. Did I do these before? No, I didn't do these. Let's look at this one. All right, let's see, what does this print? So it's going to be, there's going to be an output. What is it going to print? Let's use this space to keep track of our variables. We do have an I, we have an N, so we have 2 variables now. I'll put N first because that appears first in the problem, in line 1. So we have, this is the first statement that runs. That's the second statement that runs. That's the third statement that runs. 1, 2, 3. Once we complete each of the 3 statements sequentially, we're done. Of course, the second statement is a loop, so there's substatements which get repeated. So in the beginning, in the first statement, we declare an N and assign it the value 10. So N is 10. Right now. Won't be 10 for long. It's 10 right now, however. And then we enter into this loop. And in the loop, we use I. And if you look inside the loop, we're modifying N in the loop. And the loop condition does not depend on N. It just depends on I. We'll execute line 3 as long as I is less than 40. Execute line 3. Do the end of loop operation. This is, so, I needs to change. The substatements don't modify I, but this is a for loop, and we have an end of loop operation, which is to increment I. So think about it. We're going to execute line 3 when I is 0. And then we're going to increment I to 1 and execute the substatements. Then increment I to 2 and execute the substatements, and it'll continue until we hit 39. Are we going to execute the substatements when I is 39? Yeah, because 39 is less than 40. Are we going, then we're going to increment I will become 40. Do we execute the substatements when I is 40? No, we're done. How many times do we execute the substatement? Do we execute the substatement 39 times? Or 40 times? Or 41 times? Now, this is a problem. This is a classic problem in computing. It's called the off by 1 problem. It's so common. They have a rule for it. Off by 1. It happens constantly. So this is where you slow up and say, all right, I know roughly where the loop ends. It either runs 40 times or 39 times or somewhere around there. But I'm going to be off, I might be off by 1. So I have to stop and think carefully to get it exactly right if that's what I want. So it's very common. You'll see it as a recurring theme for the remainder of the course, that there'll be situations where it's easy to be off by 1. So how many times does the loop execute the substatement. The substatement n equals n plus 3. How many times does that run? Remember, it runs when I is 0. It runs when I is 1. It runs when I is 2, and so on. It runs when I is 39. And that's the last time the substatement runs, because when I hits 40, the for loop is done. And we don't execute the substatement for I equals 40. How many times does the substatement run? 40. Because we start at 0. We started at 1, it would run 39 times. But we start at 0. So 0 to 39, that's 40 times. Now look at the substatement. We're adding 3 each time it runs. We're adding 3 to n. So how many 3s are we adding to n? 40. We're adding 40 3s to n. So how much are we increasing n by? 120. So when we get to this point here, n will equal 120.
Would it be 130 because it started at 10?
What's that?
It started at 10, so it would be 100.
Oh, you're right. We start at 10. So we're adding 120 to 10. That's 130. So we start at 10. So when I is 0, I'll do it like this because I is sort of driving n, so I'm going to move it up like this. When I is 0, n will hit 13. And then when I is 1, n will hit 16. Like that. And then it'll hit, maybe this is too confusing, then it'll hit 19, and so on. And when n is 39, it'll hit 130. Maybe that doesn't help. We start at 10, we add 43s, so n becomes 130. What do we print? We don't print 130, we print n plus 2, we print 132. All right. Did I do that too slowly? All right. So you got to practice these. There's a bunch in there. There's a couple more in there. This one's tricky here because we're doing integer division. See? When I is 66, I'm going to go I equals 66 divided by 2. That'll be 33. Right? But then in the next iteration of the loop, I'm going to do I equals I divided by 2. I'm going to do 33 divided by 2. What's 33 divided by 2? 16. It's 16. It's not 16 and a half because that's floating point division. This is integer division. So this is a tricky question. And you're going to keep doing that. You're going to keep dividing I by 2 as long as I is bigger than 3. And then when you're done, just print I. So that one's a little tricky because of the integer division. All right. Any other questions? I think we're at the end here. All right, that's it then.